Hello, this is a video for Math 105, College Algebra. I'm working on section 1.5, which is on solving quadratic equations. Probably a review for most people that have at least recently had intermediate algebra, but that's okay. I'm going to work through the group worksheet. Again, this is something in face-to-face I normally do in class, but since we're remote, I post it, so please, look at it. You can work on it yourself, and then I make a video of me solving it. Okay, problem 1. A rectangular pool has a perimeter of 32 feet and an area of 55 square feet. What are its dimensions? Okay, I like to start word problems like this with a picture, if I can. So it's a rectangle. Let's let L be the length in feet. And let W equal the width in feet. Okay, now we're dealing with perimeter and area. So perimeter, P is, it's L, W, L, W, going all the way around. So it's 2L plus 2W. Which you might find easier if you factor out the 2. Okay, area, it's a rectangle, so it's length times width. Perimeter is total length around. Area is how much it takes to cover it, with square units. Okay, now for our problem, we know what these things are. We know that the perimeter, 2L plus W, has to be 32 feet. And the area, L times W, is 55. Okay. I could probably solve this just by guessing and hoping that I use nice numbers, but let's go through without guessing and work it out. Okay, I've got 2 equations, 2 unknowns. Let's solve one of these equations for one of these unknowns, and then I can substitute in the other. Look at this first one. 32 is even, so if I divide both sides by 2, I'll just get L plus W is 32 divided by 2, 16. So say if I want to solve for W would be 16 minus L. Subtract L from both sides. Okay, now 16 minus L is W. So let's plug that in here. L times W, 16 minus L, is 55. Okay, so now I have a single equation with just one unknown, L. That's goal number 1, right? One equation with just one unknown. Then you can try to solve for that unknown. So now we want to solve for L. Once we've solved for L, I can use this guy here to figure out what W is. To subtract L from 16. Okay. Well, let's expand this out. L times 16 is 16L. L times minus L is minus L squared. That's 55. So notice I have a quadratic equation. So I want to write that as well, I guess you don't need, but ax squared plus bx plus c equals 0 form. Right, need general form. General form set to 0. Okay, so that means That means I either have to bring the 55 over here or bring all the other stuff to the other side. I'm going to bring all the other stuff to the other side in order to make the L squared positive. So if I add L squared to both sides, subtract 16L from both sides, then this will be 0. And when I move the minus L over, that's positive L. When I move the positive 16L over, it'd be negative 16L. And then the 55 just stays. Okay. Once you've got it in general form equals 0, you can solve by quadratic formula, factoring, completing the square, that kind of thing. Also graphing. Okay, so let's try to factor. Usually, if it does factor, factoring is the easiest. So this is 1, so we're just looking at factors of 55. So 1 and 55, minus 1 minus 55, 5 and 11, minus 5 minus 11. Not that many factors. Do any of these sum to negative 16? Yes, we got a winner. So that means this here on the right-hand side is the same as L minus 5 times L minus 11. You could double check this by multiplying it out. Notice last, that's where you get the 55 minus 5 times minus 11. And notice outside and inside added up is where you get the minus 16. Okay, so now since it's factored and equal to 0, we can use what's called the zero product rule. If a product, this factor times that factor equals 0, then one of the two factors, or possibly both, have to be 0. So this means L minus 5 equals 0, or L minus 11 equals 0. Well, this would be L is 5, and this would be L is 11. Okay, now use this here. If L is 5, then W is 16 minus 5, which equals 11. If L is 11, then W is 16 minus 11, which equals 5. So basically the dimensions, it's a 5 by 11 rectangle. So I've drawn it so that the longer side is the length. So this would be 11 and this would be 5. So the way I've drawn it, it would be this one. But you could rotate it and it'd be the other way. Okay. That one factored. I could have used some other one, but let's just go with that for now. Let's try the second problem. On this page, I'm going to move this up, make sure you can see it. Sure. Okay, the square of 3 less than a number is negative 12. What are the possible values of the number? The square of 3 less than a number. So let x equal the number. Now I want the square of 3 less than a number. So this is where English language is a little weird. I want to square not the number. I want to square 3 less than the number. So what I really need to do first is to write what expression represents 3 less than the number. Well, we take the number and we subtract 3. So this expression, this is 3 less than x. Okay, and now if I want the square of that, that would be this thing squared. So that's actually what I want. I want the square of 3 less than a number. Now a lot of people would write this. Okay, but this is 3 less than a number squared. See here, you square it first, then you subtract 3. So that's 3 less than a number squared. That's not what we want. We want the square of 3 less than a number. So notice the difference. This is not correct in this case. Okay. And what do we know about that thing? We know it equals negative 12. So here's our equation. The square of 3 less than a number is negative 12. This side is a perfect square, so I can solve this problem by taking square roots. So if I take square roots of both sides, solve by square roots. So I need to take the square root of both sides. The square root of something squared is just that thing, as long as on the other side we put a plus or minus. Okay, so this thing just becomes x minus 3. This becomes plus or minus square root of negative 12. Okay, well, we did complex numbers, the square root of negative 12. Let's simplify that before I do anything else. Plus or minus, the square root of negative 12 is the square root of 12 times the square root of minus 1. Right? And the square root of minus 1 is I. So x minus 3 equals plus or minus the square root of 12 times the number I. So this part here, the square root of minus 1, just becomes the number I. Some people like to write it this way, I times the square root of 12, so that it's clear that I is on the outside. That's fine. I'm used to writing it on the right side, but make sure the square root doesn't go over the I. It's not the square root of I. Okay, and now we just add 3 to both sides to get x. X is 3 plus or minus the square root of 12 times this number I. Now, the square root of 12 is not reduced, so we should reduce the square root of 12. The square root of 12 is 4 times 3. And I did it that way because 4 is a perfect square. So this is 2 square roots of 3. So the final answer should be 3 plus or minus 2 square roots of 3 times the number I. So this is actually two numbers. It's 3 plus 2 square root of 3i and 3 minus 2 square root of 3i. Notice those two numbers are conjugates, and that's always the case when you solve a quadratic equation and get a complex number as the answer, that it's always a pair of complex numbers, conjugates of each other. Okay, that's section 1.5 group worksheet.